Completing the square is a process that will allow us to transform a quadratic function in this form into a quadratic function in the standard or vertex form. The process is a relatively straightforward step-by-step procedure. Note that the process I am describing will require that the coefficient of the squared term is a 1. We will see what to do later on when the coefficient is not a 1. First, identify the b term. This will be the number in front of the x, not the x squared, just the x. After dividing it by 2, you will square it. The number which you get as a result, you add and subtract at the same time. Since you added and subtracted the same number, you are only changing it by 0, which is great, and you then factor the result. Let us take a look at a series of examples which will illuminate how that procedure is played out. Consider the function f of x is equal to x squared plus 4x minus 6. We will rewrite this function in standard form. First, either with parentheses or mentally, I will isolate just the first two terms. When we complete the square, we actually don't really care too much about any of the constant terms. We'll take care of that at the very end. My b term in this case was the number 4. Half of 4 is 2, and 2 squared is again 4. So I will add and subtract 4. Since those parentheses are not strictly necessary, I can immediately bring the minus 4 out from within them. Factoring x squared plus 4x plus 4 results in x plus 2 squared. I then combine the minus 4 and the minus 6 to get negative 10. This is our final answer. Let's take a look at an example where the leading coefficient is not 1. Once again, I isolate my focus to just the first two terms. However, this time I factor the number that is in front of the x squared out, so everything in the first two terms is divided by 3. My b term is 6, half of 6 is 3, and 3 squared is 9. So this time I add and subtract 9. Notice that they appear within the parentheses. This time, to bring the minus 9 out of the parentheses, I must multiply by the 3 which is sitting in front of the parentheses. Here is the major difference between when we complete the square when the coefficient is 1 versus not 1. We finish completing the square by combining the like terms on the outside, negative 27 plus 5 giving us negative 22, and by factoring the part in parentheses. X squared minus 6x plus 9 is the perfect square x minus 3 squared. In our final example, we'll take a look at an example where the leading coefficient and the second term do not share a common factor. As before, our focus is entirely on the first two terms. We factor the leading coefficient of 7, dividing everything inside the parentheses by 7. Take a moment and try this out for yourself, but 12 over 7 divided by 2 is 6 over 7, and 6 over 7 squared is 36 over 49. While there are fractions in this problem, do not let them get in the way of the procedure. The procedure is exactly the same. To bring the negative 36 over 49 out of the parentheses, I must multiply by 7. That 7 cancels with the 49 in the denominator, leaving me on the outside with negative 36 over 7. Remember that when factoring the trinomial, it always works out to be x plus or minus half of b, so in this case it's x minus 6 over 7. To simplify the outside, I do need to find a common denominator, which in this case is 7. Ultimately, after factoring and combining like terms, this is my final answer. While fractions can be challenging, the procedure remains the same.